Okay, so I think let's get the show on the road. Does everyone have a pink sticky note and instructions? You should have picked it up in the back. Just a quick note. Helping with this tutorial today will be Mitch. Mitch, there you go. If anything goes completely wrong and code just starts spitting weird answers at you, please just stick your pink note on top of your laptop so I can actually see that I've completely lost half of the room. So it's a nice indication for me to see if I'm going too fast or a little bit too slow. And I'm sure Mitch will help you if there's something seriously wrong. Okay. Good morning, everyone. Welcome to Use R 2018. I hope you are as excited as I am to be here and see what this conference has to offer over the next few days. To start off, let's see. I hope you're at the correct venue. I'm Hanyu Odendaal. I'm from Cape Town, South Africa. I've been in the industry as a practicing data scientist for the last 4 years, and recently started actually and quit and started my PhD. So a lot of the stuff you'll see today I actually employ as part of my research. So just to give you a quick overview of what we will be doing today, the links to the slides and the code you should find on the little slip that I handed out to everyone. So if you can't find it, it's also up there. But first things first, let's just quickly see what we'll be doing today. So I want to get quite a lot done in session 1. So first of all, we're going to start off with ethics, because I think it's one of those sort of gray areas of web scraping. We're going to have a bit of a chat there. Next, I'm going to show you how we can use the robotstxt package to actually get a better idea of how the website is built and which of the paths we actually allowed to enter with our little scraper that we're going to build. Next, we're going to be looking at Rvest, good old Hadley Wickham package, made for scraping static websites. So we're going to just learn some of the pure basics over there, and then I'm hoping that we get time to actually connect our RSeleniums to our Docker. How did everyone at least get Docker toolbox installed? Okay, most of you, well done, well done. Just as a show of hands, who has worked with Rvest before? Okay, one. That was a good sample. Okay, so I'm going to show you guys the basics today, and hopefully we can roll that through straight into RSelenium. Session 2, we're just going to look at RSelenium, some basic functionality, and then driving your browser around. And then we're going to use this newly found knowledge that we have gained today to get to know the Australian wines a little bit better. Okay, so ethics. I think it's one of those interesting topics. With great power comes great responsibility. And if you've ever read some of the blogs out there, there's no real fixed law at the moment for what is what you can do with scraping and what you can't, especially when it comes to public data. So I think there's a big distinction we all have to separate here, just in ethics and law. So who thinks scraping public data is illegal? So if it's on the website, you can view it publicly. Are you allowed to collect it? Anyone? Do you think it's illegal? Legal? No. Good job. So yeah, there is no clear rule at the moment. So yes and no. The law is still undefined, and we still have to catch up a lot in terms of online data collection. But that being said, we're going to learn today how to at least not be malicious in our web collecting. We don't want to look like a DDoS attack hitting a server very quickly. So we're going to learn a little bit about crawling delay a little bit later. And then if you are working at a company, one of the sort of topics that always come up is how can I make sure I don't expose myself to the company or the company in very sort of ethical manners? Well, personal data is a big no-no. So if you're collecting on a website and there's things like emails or contact numbers and names, just never touch those. You can get in quite a lot of trouble. So there was this blog written a while back, and you can find the link there, and I think this blog has become known as the 10 Commandments of scraping. So if you ever start building your own little scraper, think about these small little things. So now, rule number 1, I shall go through the appropriate channels if available. So if a website actually provides you an API, use the API. You're more likely to actually get the data that way, and you don't have to actually go through the website and breaking it down. So consider the poor sysadmin. So if you've ever run a server on your own, you realize that it is quite a pain to keep a server up and going. So you can actually provide what's called a user agent in your scraper. And how does this work is it attaches to the header, and you can actually add an email address that says, if you find my scraper being malicious, please mail me at X, Y, and Z. So that's sort of just nice conduct. I am not a robot. So this is one of the big things of scraping. So as you start out, you build your little scraper and you run a for loop, and you suddenly realize that you're hitting the site at 100 times a second. So what you have to realize is that you have to play nice with others. You have to let your robot little sleep and then go and collect the next bit of information. Okay, a big one. I shall not become addicted to data. So collecting data and web scraping can be a lot of fun. But the more you collect, the more you have to realize that you're not able to actually store everything. So only take what you need. Okay, the last bit, I shall not plagiarize. So I shall not build another site using another site's data. Not just interesting, so don't actually just scrape data for the sake of it. Try and create some new value from the data. And most importantly, realize people are people. So why are you scraping this website? I've had experiences where I've tried to scrape a website, a really big website, to collect PDF documents, and after like a month and a half of a scraper running on a little AWS machine, I realized that it's going to take like 6 months. So I just mailed the people and I asked them, can I just send you a hard drive and you actually just upload this? And they were kind enough to actually mail it. So within a week I had 0.5 terabyte of PDFs delivered to my front door for free. So, always see, maybe contacting them people might be easier. And then most importantly, you're responsible, not your boss. So you're the expert, and guide your managers and highlight when you're uncomfortable. Okay, so that's a nice theoretical sense. So let's get into it. Okay, so the first package that we will be using today is called robots. So if you haven't got robots, install it. I already have it running. So you're asking, what is a robots file? So a robots file is actually a file that's embedded as part of any or most websites, and it's actually sort of it's an informal institution that websites hold, and there is no authoritative list of robots and how things work. But you can see how the format looks of a very, very simple robot file, and it says for user agent all, it means disallow CGI bin, disallow temp, and disallow Joe. And then you can actually specify for specific robots which of the websites it isn't supposed to go. So this website said, any robot, you can go wherever, but just don't go into the CGI or temp. And for user agent Google, so Google's robot is a disallowed nothing. And then, the worst of all is if you see one of these. So this means any scraper is not allowed to enter my site. But nothing is blocking you. Okay, so this is where this moral and ethical code sort of comes in and becomes a little bit gray. So let's have a simple example. Okay, so let's go back to RStudio. So I'm going to use this robots package to actually go and collect a robots file from the FBI. Okay, so let's have a look there. So you should get something like this. Can everyone see? Must I make it a little bit bigger? Cool. That a bit better? Hope so. Okay. So does everyone get this little robot? So the crazy thing about the FBI's website is it almost allows us to go anywhere we want. So it says, you know, by default we allow robots to access all area of our site already accessible to anonymous users. You know, and you can actually find interesting interesting comments in these little robots. No. Okay. So here's another example is once you've loaded that robot text file, you can actually check for comments. So here the FBI says, you know, by default we allow robots, the wildcard is only supported by Googlebot, and so on and so on. We can also use this to actually have a look at, you know, where are we permitted to go. So you can use your file permissions to then have a look at where anyone is allowed to actually go. So you can see it says that we're not allowed to enter, you know, the login forms, mail password forms, pretty much a structural component of this website we are not allowed to actually touch. Another nice sort of feature is this package actually allows you to specify a certain path, and then it tells you whether this path is allowed or not. So let's have a bit of a look at where I'm going here. So if I was to go to, let's say, another government organization, such as the Reserve Bank of Australia, you know, maybe I would like to see what speeches are coming out, and I'd like to draw on those speeches and scrape them at a regular basis, but I don't know if I can, if I'm allowed to actually scrape the specific path. Then I can get the URL. We're going to jump back to our little robots. We're going to look at paths allowed, and then I'm going to just paste that link in. And then it actually goes and it pings it and it looks for that specific path. Now we know we're actually allowed to go crazy and build a little robot that goes and collects that information piece by piece, and it's actually allowed. So they're not going to block us for some other very strange reason. So cool. So, okay, so we can do one path, right? But another nice piece of or function, piece of code, is we can actually add multiple paths. You know, so if I'm going to crawl around a website, looking at multiple pieces. So what I was looking at here is if I'm looking to go to speeches and I want to troll this, and then I'm going to go on to maybe publications, because maybe I want to see what minutes the Reserve Bank release, what they're saying about monetary policy, those kind of things, I can actually copy this last bit of path, and I can build, using paths allowed, a vector implementation of paths allowed. So you can see I'm specifying paths allowed, the specific paths I'm interested in, the domain name, and then the specific bot. Because certain bot has got certain sort of scraping rules, and if you ever worked with Python, so Beautiful Soup and Scrapy and those kind of ones, they actually have their own crawl delay built in, and sometimes the websites are not too happy with the way they sleep and actually collect information. So they will actually ask you not to scrape with a specific scraper. So if you're using a certain type of technology, just type it in there and have a look. So let's see. Okay, so in this case, we are allowed to actually enter this whole website. Okay, so let's have a look. So this is kind of a small example of robots, but let's have a look at a proper robots example. So I like the Wikipedia one. So as you can see, it's usually the URL, and then it adds robotstxt at the top. So as you can see with Wikipedia, it's quite an extensive robot file. So we can actually have a look at multiple scrapers. We're probably mostly interested in all here. We can actually see if rcurl, which is the scraper for R, is in here. No. Curl commands, no. Let's see if Googlebot is in here somewhere. Yeah, it's downloads. Okay, so yeah, you can see media partners, Google, they're not allowed to touch the Wikipedia site. Yeah. And spend some time in these text files, because they're written by like sysadmin and programmers. You sometimes find quite interesting little comments and yeah, little piece of gold hidden in between them. Okay, so I talked a little bit about crawl delay. Now, does anyone here know, except for the one man over there, sort of what a crawl delay is? Anyone's got an idea? A little bit? No? Okay. So let me show you something quickly. So let's say I want to read in a website, and I want to read in 10 pages of this website. And I go for I in 1 to 10, so I guess I'm going to read in 10 pages. And let's just say, I'm going to call this example. And imagine that this hello, let's call this hello website, is a ping to that website. Okay, so what's going to happen if I run this, right? It's going to instantly actually loop through that website, and it's going to hit that website very fast. And if you're a good sysadmin, then most likely you're going to see this as a DDoS attack, and your IP is going to get blocked instantly. So what we'd like to do is we'd actually like to put a little sleep in, so a crawl delay before you actually go to that next page. So the nice easy one we use, sys.sleep. Okay, so now I'm actually going to do half a second just because of time. Okay, so now you can see our scraper is a little bit more elegant in the way it goes about this. Okay, so, but what do you think is going to happen if I put in a constant in my sleep? You're also going to get recognized as a robot, right? So anyone got an idea how to fix this? Exactly. So what we're going to do is we're going to use runf. Give me one between 2 and 3. Okay. So uniform, and now we're going to sleep. I don't know for how long, but now you're starting to be a little bit more disrespectful. You're not coming in at a constant sort of time frame, and that's sort of the basic fundamentals of how you would go about iterating over websites and how crawl delay is actually implemented. So like I said, as part of this commandments, we aim to listen to a website, and most websites are actually nice enough to give you a crawl delay in the website. So I think let's go back to Wikipedia and let's maybe check. Okay. Can read a minimum delay between hits. If your bot supports such a thing as a crawl delay and other instructions, please let us know. So low speed bots are welcome, and so on. So actually most websites will have this, and you can actually have a look at what they recommend that their server can use or can actually handle. But sometimes you'd find that these crawl delays aren't there. Okay, so what are you supposed to do then? Well, to be honest, someone actually went and had a bit of a look. So this is sort of the distribution or the sleep cycle for 80,000 websites. And what you can see is that the big crawl delays are at around 5 to 10 seconds. So if you know nothing else, then add a small crawl delay of about 5 seconds, and you should be respecting the sort of website's way of going about it. Okay, so I usually enjoy a very verbose output in scraping, just because, I don't know, there's something about watching your scraper tick along and knowing, like things are going on. So what I usually do is I usually build a nice little function for myself. And here you can see I built a little function called night-night. And night-night's got this 2 inputs, right? So I'm going to tell it period 1 and period 2. And then I'm going to actually generate a random number between 1 second and 1.5 seconds. And then I have the sort of very ugly cat command here. And then I'm going to sleep. Okay, so when I run this command, it will actually give me a nice sort of time frame. So let's do this. Okay, so put a nice space in there. Okay, so as you can see, here's my function. And now, instead of this sort of ugly sleep, I can just put in night-night. And I want to say, because we, all need time here, I'm going to put that between 0.2 and 0.3 seconds. Okay, so let's see how this goes now. Okie dokie. Okay, so now you've got a really verbose output. You know what's taking long in your scraper as you're collecting. You have time frames for when these things are collected. So I would definitely recommend, if you ever sort of start your little scraper, build a nice sleeping function. Okay, so that's sort of the basics done, right? So let's get to Rvest. Okay, so does everyone have Rvest installed? Okay. So as it loads, you should see library is acquired, XML2, which is sort of on which Rvest is actually built. Okay. So I think one of the reasons I enjoy scraping a lot is because it lends itself a little bit to functional programming, and you'll see why in a bit, because what you're going to do is you're going to look at a website, and there's going to be a command that you want to do a lot of times. So you want to say maybe, I want to connect nameplates, and I want to collect GPS, and I want to collect this, So if you do that in sort of a continuous manner, then, your script sort of runs through a lot, and you have to repeat a lot of the code. So what I usually do is I write myself small little functions that does the same thing over and over. And one of these that I actually use often is a little function to check for my API. So there's this link called api.ipify.org, the format JSON. So if we go there, we can actually see, it's quite small, but you should be able to see it a little bit better on your screens. Okay, but this is a way for me to actually test my IP. Okay, so let's build a small little function using Rvest now to go and collect this IP and pass it. Okay, so number one, we're going to use the read HTML function. Sorry. Okay, paste it in, run it. Okay, and you should get something like this. It says, well, read HTML has returned a document class of XML document. And you should see your little IP there. Okay, but now the problem is, as soon as you try, let's see, parse it. So I'm going to use JSON Lite. So if you haven't got JSON Lite, quickly install that. So I'm going to try and use JSON Lite to parse this document now for us. Okay, from JSON. Okay, so let's see what we get. Well, it tells you the argument text must be a JSON string, URL, or a file. Okay, so what's the problem here? The problem is that when we call this function and we read in this website, we actually get a class of XML document. I think the internet is quite slow now. Timeout was reached. Fair enough. Okay, but the way to fix it is, well, not fix it, to build a pipeline is to parse this document into text. So how are we going to do that? We're going to use the HTML text function, and you can actually trim this if you want. So we're going to read this HTML, we're going to pipe it into text, and then we're going to actually bring it into JSON. So let's see if we win now. Okay, starting to. Okay, and there we go. So now you can see that I've created actually a nice small pipeline for myself already. Okay, so all I need to do now is I need to wrap this in my own function. And once you have this done, you now have essentially built your first Rvest function. Well done. Okay. So, easy enough, and that's Rvest. No, just kidding. Okay, so once you've gotten used to the sort of syntax of, okay, I need to read in a website, you know, if it's only a small part of the text that I'm actually reading in, I'm going to pipe that into HTML text and then pass it further on. Okay, so one of the things you would have seen is this idea of me bringing back a XML document. Okay. So one of the things you need to start learning is what's called the DOM. So the document object model. So let me show you quickly. Let's say that I'm going to actually read in Jeeves. So ars.com, I'm sure it still exists. Okay, so this is this website. It looks quite plain, right? So from a visual view, this website does not look like much. But as soon as you press F12 to go into developer view, you start realizing that this website is actually a lot more than it seems. So this is the sort of part of the website that you must get familiar with, and this is called the DOM. So, what is this DOM? So the DOM is, like I said, a document object model, and it's sort of a programming interface for HTML and XML documents. And this DOM is a representative of the document as a node. So you've got nodes and objects in this document, and it's a way, so sort of we programmatically will go around investigating the specific web page. So, like I said, DOM is an object-oriented representation of the web page, which can be sort of modified and accessed, right? So if I click on this div over here, so this is object div of a class left L footer content visible. Okay, so if I go to RSGs here, as I move around, you'll see that at certain parts of the website is actually being highlighted. Do you see it? Okay, so that's how you know which part of the website is in which part of this DOM tree. So I can actually open this up, and I can look for the specific, for the search bar. So I can either do it by just playing around, or I can actually use what's called this CSS sort of selector. And if you've got Chrome, it's very easy to get it. And you can click on it, and you can just click on the object you want. So there we go. We can see that this is this input, and it's class search box input. And the important part is here at the bottom. Okay, so here at the bottom is actually the CSS, or the path we can use to actually identify that object, right? So if I want to now grab maybe this partial home wrapper logo, how I'm going to go about this is I'm going to grab that specific node. And Rvest is easy enough. And how we're going to do that is we're just going to say HTML nodes. And if I have a look at this partial home wrapper, and let's see here. Okay, so I'm actually going to grab, I think, the search bar. So div.searchbar. So if I grab that, let me just have a look again. Search dash bar. Okay, I can't find that one. I need a... Okay, so now you can see that what I've actually done is I've taken this, let's see here, this XML document, and I went and isolated a certain node. And this sort of flow is the majority of Rvest. You're going to grab, you're going to read in an HTML, and then you're going to go and grab a node. So you can see I went from an XML document, and now I'm at an XML node. If there's multiple nodes, you can actually grab them by just adding an S. So here we can see that in this web page there's only one sort of node which says class search bar. Okay, so let me go over that again. So if I'm looking for sort of a certain part of the website, I can open developer tools, and I can actually use a nice selector to look for the element in the page that I'm looking for. Okay, once you've isolated this element, you need to look at the CSS path to that element. So I'm assuming it's quite difficult to see on your page, but this logo is a div.partialHome wrapper logo. I think I'll be able to grab it if I... There we go. So you can see how you sort of, as soon as you land on a web page, the first thing you do is you press F12 and you look at it from the back, because then you really get a feel of how the web page is built. And if it's a sort of, if the people built the web page mostly from the ground up, their div classes will sometimes be very nice. So it'll sometimes be, you know, div.main title, div.location, and you can easily grab those nodes in like one file swoop. Okay, so let's get back to this. Okay, so this idea of the DOM is that there's this HTML object, and we're going to interact with this DOM as if it's a tree. So if you want to get to know a little bit more about how to specifically specify these trees, I would recommend there's a small little link at the bottom that you can actually go to, and you can actually learn a little bit more about how these trees work, you know, how they're built from the ground up, and what specific sort of node you will actually encounter. So now I just used a div. A div is the most basic one, but sometimes all of your objects might be in a list object. So like this is a list object, and you might want to create like collect only those specific list items. So getting sort of familiar with what a DOM is and how it is constructed becomes quite vital in getting around a website. So one of the sort of key ones out there is that a table has got a certain kind of object. You know, so what's quite nice is that Rvest actually has a wrapper built around identifying these table nodes. So instead of me going and having to scrape the specific node, I can go and I can just use HTML table. Okay, so Rugby World Cup, being South African, obviously we do follow this quite extensively. So if I'm interested in, you know, maybe having a look at attendancy figures. Okay, so there's this attendancy figures element in the Wikipedia page. So if you can go to Wikipedia, Wiki, Rugby World Cup. So if you go there, you'll see that there's this attendance page, and again, I don't look at a web page in this manner. I press F12 and I get to work. So let's have a good look here. So if I go and I isolate this table, you'll actually see that, awesome, you know, this little attendance table of ours is a class of table, and you know, there's the rows and the columns, you know, so I can actually scrape this table using HTML nodes, but then I'm left with having to, you know, data munge and you know, gsub and all kinds of strange things to get that information out of the table. So if you have a table object, what's really nice is that you can use Rvest's HTML table function. So let's have a look. So I'm going to get this link over here. Okay, so again, first part is we have to read the HTML object in. So sort of a quick tip is once to sort of read in and then, you know, so using that piping notation, that feels natural, but I recommend for scraping that you read that page into your environment and then start the piping, because otherwise what you're doing is you're doing calls to that server every time you're running your pipe chain. And also you make mistakes, you know, because it's sort of it's more of an art than a science sometimes. You know, you sort of think you have a node, and then you call in the nodes and you realize, oh, there's actually 5 of these hidden nodes in the back, you know, and you try and figure out where they all come in. So you have to play around a little bit. Okay, so let's have a look. Okay. So here you can see, here's my page. If I now look at this page, it's just a massive blob of text. Okay. So if I was to actually go this route, I would need some pretty sick regex skills to actually get that attendance table out. But luckily for us, we don't need that. We can just use HTML table. Okay, so let's call this rugby. Oh dear, okay, so it says, well, I'm quite sorry that this table is inconsistent number of columns. Would you like to just use full? So what it's going to do is now going to read all the table in, and where the tables are inconsistent, it's actually going to fill them with NAs for us, which is actually quite convenient. Okay, so if we look at this list object, rugby, if we look at this now, we find, oh dear, there's like a million of these tables. So we didn't really consider, that, yes, we wanted this one table, but actually embedded in this Wikipedia page, there's about 19 tables. So, like I said, more of art than science. What I usually do is I just have a quick look. Okay, that's not it. Okay, that's not really what we're looking for. Okay, there we go. So the third one is the one that we actually need. So you'll also find that a lot of, with the sort of RVest and Selenium especially, you're going to be working with list objects. Because they're sort of unstructured sometimes, it's difficult to press it all into a data frame. So get used to sort of working with lists. Okay, so if we've got our rugby, we're going to actually put this in a table. Okay, now we can have a nice look at this. Okay, so what we see is we have year, host, attendance, matches, and now we can actually start doing our cleaning. So I'm going to actually just copy and paste this code and I'll take you through this. Okay, so I've got my table ready. Let's just do this. Okay, so the first thing that I saw is that, this total attendance column has come in as a character because we've got commas in between. So I'm actually just going to ask it to remove that comma, or I'm going to go the smarter route, right? Because there might be all kinds of other symbols and strange things in there. So I'm just going to ask it, take rugby tables. We know it's the third one. Please make it a tibble for an easy read. And then mutate and create this new column from total attendance and give us only the numerical numbers. Sorry. Okay. Why is this mad? Oh, it's because I actually did this. Come on. Oh, sorry. Okay, here we go. Okay. So now we've added an attendance column right at the back, and we can actually have a look at how this looks. Okay, and you can see that we've been successful in pulling out all of the numbers The reason why there's an NA in the back is because luckily for us, we specified numbers only, so to be determined has now just become an NA. And then we can go on and we can conduct our analysis. So for me, I scraped this table because I really was interested to see, what's attendance numbers over the years for the Rugby World Cup. So if we have a look, you should be able to then sort of get a nice little graph going with a bit of ggplot knowledge. So you can see how Rvest sort of quickly takes information from the internet and passes it so that it's easy to use and easy to display and easy to examine. So HTML table is very useful if there's a table. But if there isn't a table, we need to use nodes. So nodes, again, is what I talked about, where you're going to isolate that one piece of text, or that one node in that HTML document. Now, there's two ways you can do this. There's XPath, and there is the CSS selectors. So if you're a little bit more familiar with HTML, you can use XPath, which has got this notation. So this says, okay, for all kinds of objects, I'm looking for a class where ID equals TOC. And it's a little bit more abstract. So I find in the beginning that if you're going to use XPath to find nodes, it can be quite difficult. So I prefer just using the CSS selector. So you're asking, well, how do I get to this div.toc? So what I wanted to do was I wanted to find out what's the table of contents of this page. So if I look at my Rugby World Cup page, and I go up to this table of contents over here, I wanted to collect that information. Because I might want to actually follow some of these links around. So I use my selector tool, I move it around a bit, and I get to that table of contents. And as soon as you hover over that, you'll see that it's div, and then it's separated by the dot, TOC, TOC. So this is, it's a div with an ID tag, TOC, and a class, TOC. And once you have that, then it's easy as 1, 2, 3 to actually collect that information. Yeah.
Notice if you haven't used the inspector gadget. Is there a specific reason, or is it because you found that you don't need to once you put it in?
Yeah, so okay, so a very interesting question. So what he's talking about is called the inspector gadget, and it's an add-in that you can get. Okay, so you can look around for it, but this is how it looks. So it comes in, you install it, and then you can move around with this inspector gadget, and if you highlight this TOC, this table of contents, as I just did, using the conventional Google one, you'll actually see it brings up nicely for us it's a hash TOC. So the nice thing about the selector tool is that you can actually select sort of, okay, I want this paragraph, but I don't want that paragraph, and so on. To be honest, I found it sometimes gets it wrong, and can be sometimes a bit too wide for me. So I found that I prefer the CSS tool, mostly because that's sort of where I started, and also because I've had the CSS selector let me down. Yeah. Especially sometimes because for the CSS selector, if I'm scraping, so I'm scraping this website or this specific page now, right? And then I want to scrape this part, so it grabs P for me, but I only want to grab the top parts. So for this specific page, you will see that it tells me, okay, I'm going to go into this paragraph, and then I'm going to grab the 8th child. Okay, so that says go into my web page, look for a specific class paragraph, and then select the paragraph and the 8th child in that selector. And the problem is, as soon as you move to like a new page, that paragraph might be a different sort of place in the node, and then it breaks again. So yeah, so I think this is from like a bottom up. I prefer top down approach. Yeah. Okay, but play around with it. I mean, it does help. Like I said, more of an art than a science sometimes. Okay, so that's TLC notes. So I want to show you something fun, because I think seeing these things in isolation can become, tedious, and you're like, well, how am I going to apply this? So what are we going to do today for the next 10 minutes or so is we're actually going to investigate drug tests. So one day I stumbled across this website, and this website is called ecstasydata.org. And to be honest, I think it's one of the funnest websites as far as scraping goes, because you actually go in and then it gives you, they have testing stations all over the world, and people can send their samples in and they will test it to see sort of what's the strength of these subjects, of the substances. If you were sold MDMA, is it MDMA, and so forth. And obviously the nice things here is also the names. So for you guys who know Adventure Time, that's there. Okay, a lot of cocaine coming in, Blue Superman. And the nice thing is it actually tells you the date that these drugs were submitted. So you can play quite a lot. There's Tesla. There was actually like a Donald Trump one on here a week or so ago. Okay, so, there's like a million things you can answer by just scraping this website. Okay, so the first thing I'm going to do is press F12, because this is not how the website looks. This is how a website looks. So here you can actually see interesting things as well. It said, okay, it actually read this from the cache, because I've already been here. But let's have a look. Okay, so I want to grab this table. Okay, so I'm hoping for, boom. Okay, so HTML table, we know we can use the RVest function to go actually grab this table. So I quickly want to show you as well is that at the moment we're looking at like 100 entries, but you can actually pump this up to about 200 entries. And you'll see that the URL changes. Okay, and that's important, because once you start moving around pages, you'll start to notice that by changing small parts in the URL, we actually get different data. Okay, so that's how you're going to move around this website, is by looking at, as soon as I press to go to like a next page, what part of, what happened there? What part of the website actually, or what part of this URL changes. So you'll see that the start of this URL keeps changing. So I'm going to scrape a very small part of this website, but if you're interested in doing some more exploration, definitely go and check this out. Okay, so just by the way, so if you don't know how URLs work, you have the URL and then a question mark, and that breaks up sort of the API. Okay, so it says, well, this is my URL, and then I'm going to start giving you parameters, and the parameters are separated by an ampersand. And like I said, I played a little bit around with the website, and I realized that if I just change that start, 0, 200, 400, 600, I can actually iterate over the page. Max number of observations, I also just set that to 200. Okay, so let's get started. Okay, so I'm going to actually grab this website. So it's ecstasydata.org if you want to join along here. And then I'm going to set this to 200, and I'm actually just going to grab page 1. Okie dokie. So we're on page 1, so I'm going to take this. Okay, we're going to get the old workhorse out. We're going to say read HTML. I'm going to read this page in. Okay, successful. And because I know and that I've looked in the sort of website, I know that there's a table, so we don't need to nosy around with divs and nodes and things too much. So I'm just going to grab this table directly from the website using HTML table. Again, you'll see that I actually went and had a look a bit about the sort of tables that we're collecting, and I realized there's more than one. So I just grabbed that second one, which I know is mine, that I'm looking for. Okay. And then I'm going to look at the head, because I pulled the table and I want to know what the contents of this table looks like. So the problem is that you'll see we collected this web page, but all of this sort of extra meta information is coming along, right? So when collecting tables, don't just assume that that is what you're going to get. So actually what I have to do is I have to create a function that just names this table correctly quickly for me. So what I did was I have my table, and then I went back to that website and I just had a nice little look on, okay, it's photo, sample name, substance, ratio, publication, and so on. So I just created a nice little function just to sort of help along the process. So this function takes in a data frame, just names it, and it spits out a table for me for easy use. Okay, so let's have a look at how this goes. Okay, so my table with all my information, I'm going to pipe that into my new naming function. I don't need to make it a table again. And then I'm just going to remove the first row, because the first row of this table has got all of that sneaky information in there. So you can see that sort of meta information has come along. So I just remove that first row, and then our table is ready for some analysis. So you need to clean the table a bit. So I'm not going to go too much into sort of how I clean it and so on, but you can go and play along. The code is there. So you can have a look at how I clean it. I then build a nice little crawl delay, and then with this crawl delay I actually put everything nicely together. So I've got a collecting a page function, which I then pipe into my naming function, which I then pipe into my cleaning function. So I've sort of built these small little functions that's going to help me along. And that's why I enjoy sort of the RVest way for collecting data and collecting collecting information from the internet. So I think another thing that's strange about web scraping is that once I've built this little pipeline now, I'm actually going to use a for loop. And I know people are looking at me like, oh, but you can just, create the sequence, map over that sequence, and that will also do, because we have all these functions, Well, and to be honest, I find that this is a perfect case for a loop. If you're doing big projects and big collecting, the web pages might change, right? So you've built this amazing function and it works on the 4 pages that you just tested it on. Awesome, my function works. You press it. Next morning you come in to check whether your little scraper has collected. Oh, on page 7 it broke. Okay, now you have to start again, and then you fix the problem on page 7. Tomorrow it's page 15 that broke. So you're sort of constantly fighting with the structure of the web page. So what I find is I really enjoy building it up in a loop. Number one, because that really nice verbose output can tell me exactly where the scraper broke. I also actually then usually save my progress as I go along, and I can also fix things as I see them break. Where if you're going to use a map function with a wrapper such as possibly, you're just going to get spit out an NA all the time, and you're going to have to go back and fix those NAs. So, build your scraper in the beginning using a loop. If you find that scraper has done a successful job, then then build it all using mapping functions, definitely, because you want to if it's going to go production, then definitely use per, But firstly, if it's a once-off little scraper, then definitely use a nice little loop. You'll also see that I build these pages using a list object. So the reason for that is that these objects that are going to come back, you don't always know what they are. So like I said, for now this page looks like it's bringing back characters. So okay, you use the function map character, and then by page 10 the map character breaks because suddenly you're getting numericals through and all kinds of weird information. So I build it up in a excuse me, in a nice little list object, and from that list object, you can sort of start sussing out where things are a little bit different. It's a nice isolated case. So yeah, use lists to sort of build all your pieces together. So like I said, I want to get to the RSelenium stuff. So go and play with these sort of frameworks a little bit, but I want to show you what can be done. Okay, so I've collected this data. So I think we all wanted to know where are the best drugs in the world. Ah, damn it, didn't work. I'm going to show you quickly where they are. So using this data, I actually collected the whole website. So I collected all of their, about, I think there's about 6,000 of them. And then I plotted them to see where are the best drugs in the world. So to give you an idea, apparently it's online. So most of the online sort of submissions are really high concentration MDMA. We've also seen, the strangest thing for me was that the strongest drugs, or MDMA, didn't come from Europe. So that was interesting, because I would assume that most of the drugs that you see on this website would have come from like Berlin or Amsterdam, but apparently not. Apparently Los Angeles, New York, and Chicago is where it's at. And then Basel. I assume they've got one of the biggest testing stations. I don't imagine the Swiss partying that hard. But anyway, so this is sort of a fun thing for me. There's like a million other things you can do on that website. I also looked at things like if there's a rave season, is there like a season where people just see the drug spike? So I implore you to actually go and play a little bit more with this sort of website. Okay, so to conclude Rvest, okay, so I've only shown you like a pinch of what Rvest can do, and it's mostly because we're trying to get to what RSelenium can do. So Rvest is an amazing package for scraping static websites. So what you would have seen is every time I press that F12 and I go look at the HTML, I can actually see the HTML. Okay, but what if that HTML is not HTML? What if it's JavaScript? So the website is generated through dynamic objects. Then Rvest doesn't work. Okay, so then we have to actually have a browser that's going to collect the information for us. So we have to simulate that browser session, and we're going to use Selenium for that. So as in sort of added extra examples, what I did was I added to this slides some added extras. So in your free time, if you want to get to know RVest a little bit more, go and read up a little bit about the HTML sessions, read up on HTML forms. It's actually amazing what the package can do. Okay, so onwards to Selenium. I think this is what most of you came here for today. Okay, so Selenium. So getting to grips with RSelenium. So I call this don't hate the player, hate the game. So has anyone ever tried to start up a Selenium server? Anyone? And how do you find it? Hard. Yeah, it is extremely hard. To be honest, there's some Java dependencies that come along that you have to install that never mind how many times you set your Java path in your R environment, it never seems to know where it is. So, so I think half the part of Selenium is just getting it up and running. So I've got 20 minutes left and I'm going to try the impossible. So I think we're going to try and set up to see if we can at least connect to Selenium in the next few minutes. Okay, so first of all, why should you care about Selenium? I mean, I just showed you Rvest, which is pretty powerful. Once you get to know it and once you get your feel around how to work with nodes, you can pretty much do most things. Okay, but the trick is that it can't do everything. For some sort of web pages, we need Selenium. We need something more powerful to actually drive around the website and keep information that's dynamically loaded. So Selenium makes our task easy as it can scrape complex web pages that actually works with dynamic content. Another big thing is if you are a Shiny developer, you can do your unit testings using Selenium to make sure everything works. We can also do human-like behavior. So we're going to click and we're going to scroll. We're going to use page down and page up. So we're going to use keys. So we're actually going to interact with this web page using RSelenium. Another reason is that they actually finally brought out the stable version through Docker. So that's part of the reason why we should be using it, because there is an easy way to actually connect to the server and how they actually do it. And then another reason is the joy you get when you finally get it working. I've enjoyed sort of machine learning things in R, and I've enjoyed sort of natural language processing, but I think Selenium is one of the funnest. You open up your viewer and you can see your web page going, clicking and scrolling, and how your code actually interacts with the page becomes incredible to see. Okay, so let's get the old boy started. So, given that it was nearly impossible to get it started, they made it a little bit more difficult, and they recently removed the package from CRAN. So to get RSelenium installed and up and running, you need to install a couple of the packages straight from John Harrison, who's the sort of maintainer and creator of RSelenium directly. So it's a bin man package, which is for binary commands, WD, and then RSelenium. So once you have all the installed packages, obviously just remember to load RSelenium straight into your environment. So I'm just going to do that quickly. Okay. So has everyone got that loaded? Okay, so once you've tried through actually get the packages installed, we also need to now start this ignition on the actual machine. So we've got RSelenium, which is going to be our code or our API that interacts with the Selenium server. So they are independent beings. So like I said, RSelenium or Selenium is actually notorious for its instability and compatibility issues. So it's actually amazing that they're starting to bring out nice Docker containers or images for this. So running a Docker container standardizes the builds across all OSs. So, you know, if you think it's difficult to get it running on a Windows machine, try a Mac. Whole nother game. Okay, so yeah, and let's not talk about Linux. So, you know, having this sort of Docker helps us to transition between the OSs and get Selenium up and running no matter what operating system you're running. Okay, so improved stability, greater ease in setting up the actual Selenium server, and it's quick up and down. If you ever worked with Docker, it's mind-blowing how quickly the images can actually spin up and down. Okay, so getting your environment set up. So if you are a Windows person, you would have installed Docker toolbox. So if you've got Docker toolbox going, please open up Docker toolbox now. So okay, it'll load a little bit and eventually you should get to screen as such. Okay, so the first thing you notice is that it tells you explicitly what your machine's IP is. So if you're running Windows, this little Docker container, or this emulator, not Docker container, this emulator, is 192.168.99.100. And we need to remember that because we're going to use that in a bit. Okay. So once the Windows, so let the Windows guys get going. If you're running Linux, you should see terminal. I don't think that's quite odd for you guys. Okay, so now let's go have a look at Docker Hub. So if we go to Docker, so Docker Hub is a sort of repository or like aggregation of all Docker images. So you can find most images up here. If you've played a little bit with AWS, RStudio is up here as part of the Rocket project. So that's also quick and easy to set up through Docker. But I'm going to use the Selenium Hub today. And I'm going to see a couple. Okay, so there's a few to choose from here. There's Selenium node, the node one, the standalone Chrome. I don't know what Selenium Hub is. But the one we're going to be using today is the one called standalone Chrome debug. So what that's going to do is it's actually going to spin up a small Ubuntu environment in the Docker, and we can actually SSH into that machine and have a look at what is happening while we're navigating. Once you're sort of happy with your scraper and you know it's all running well, I would then shift to a standalone Chrome. Because the debug version can be quite clunky, it can be quite big, so if you're running multiple of those, you know, you're using up a lot of RAM. So then just bring it all down. Okay, so let's have a look at the standalone Chrome debug. So it actually tells you, you know, if you want to know what's going on, here's the GitHub version. Okay, and now the big thing is that we need to pull this image down from Docker Hub. So we're going to use this easy pull command that they actually give us. We're going to go to our shell. I'm going to paste that in and I'm going to pull it. So you'll see that it says it's using a default tag, latest. So what that means is that if you found that a certain version of the image worked for you, then you can actually pull that specific image all the time. But for me, I find that all of them are quite stable, so I just usually pull the latest image. Okay, so it should pull quite quickly. Okay, I'm just going to cancel mine. Doesn't. Because I actually have it already. So if you go, and if it's finished, you can actually type in Docker images, and it'll show you which of the images you've pulled. Okay. So also for running Docker, you're actually going to be initially running it as root, but if you know anything about sort of security, you don't want to be running Docker as root, you want to be running it as a different user. So once you have your Docker set up, we're going to use sudo, so superuser. We're going to add a group called Docker. Okay, it's for the Linux guys. And then you're also going to add a user to that group. For Windows, you're completely fine. You don't need to add groups and do permission changes. Okay, so hands up, whose Docker has pulled? Okie dokie. Okay, so let's have a quick Docker introduction. So type in Docker, Docker images, and then hopefully your images will come up. So I've got two. I just have a hello world, which I use to test my Docker instance, and then I have standalone Chrome image. Okie dokie, so we have pulled it. Okay, so again, just a quick introduction to Docker. So there's like 3 Docker commands that you need to know. You don't need to know a lot. There's run, stop, and rm, which is remove. That's it. If you really want to go advanced, there's Docker restart or Docker start. So those are sort of very basic commands that we need to know to actually run a nice RSelenium instance. Okay, so once you've had it run, we're going to use quite an advanced, I would say, Docker command to start it. If you've seen the vignette on RSelenium, they have a very basic way of starting the container, but I've had issues. So number one, if you don't name your container, you'll get really, really strange names popping up. So I want to quickly show you. If I take this. So I'm going to actually just open up a quick RSelenium view to show you what happens. Okay, so we can see there's a hash, and if I do docker ps -a, then I can actually see that container is running. But you'll see that now Docker has actually given, it's decided on the name. So now this is called Blissful Synosy. And if we go again, it's quite mad now. But now it's Cranky Franklin. Okay, so that's quite funny and it's very nice. But now you have to work with this Docker, right? So now you actually have to Docker stop. Okay, and you have to go look for that specific one to actually stop it. So it's a little bit easier just naming your Dockers. So for that, we're going to use the name command, so --name, and I'm going to name this Chrome just so that I can easily work with my own little Dockers. I'm also going to add a -v. Now, that's for me having to mount a volume. So the Docker is an isolated image and is running in a small little container in your machine. It has no idea of the outside world. So you need to tell it, take the certain piece or folder and mount that image onto the container. So what I'm doing here is, this is for Linux. So what I found is that I need swap sometimes. So Selenium tends to crash if you don't add swap. So also the vignette doesn't specify this, and I only found this out after playing with Selenium a couple of times, that if you're in Linux you need to add your swap. So what I'm doing here is I'm just mounting my swap drive. So if you're a Linux guy, you have to add some swap. Then next is detached mode. So if you don't run it in detached mode, you will actually enter the container on startup. So you don't want that, right? You want it to be as a background process. Next, I'm going to mount ports. Okay, so Selenium connects to port 444 on default. So what I'm saying here is, I'm saying expose for me externally port 4445 and map that to the 444 on the inside of the container. So Selenium built it so that they expose 444 on the inside, and then you're saying, okay, but we're going to connect to 445 on the outside. And I like to just sort of increment the ports so I know which is which always. The next is, we're going to also open up the port for our viewer. Because we're using Selenium in debug mode, we want to connect to that viewer with tight VNC or so on, so we need to actually open that port as well. And then the Docker name. Okay, so I'm going to show you this command in one go. Let's see if this will mount. Okay, awesome. What's it saying? Endpoint. Oh, so you can see why it's complaining is I opened up port 5901 earlier with my example, and it's saying, oh, there's actually a conflict. So I need to actually quickly stop those. Okay, so Cranky Franklin created. Okay, let's just stop this. Docker stop. Okay, and then I'm gonna remove it. Docker rm. Okay, and then I can go Docker ps again to have a look at what's running. Okay, now I need to just make sure Cranky Franklin is removed as well, so we don't have ports crashing. Okay. Okay, so I'm going to restart my Chrome. Docker stop. You have to always stop and then remove, otherwise it will complain. Okay, so now I can use this again. Okay, so like I said, I'm gonna start this container with the name Chrome. I'm going to add some swap. I'm going to tell it enter in detach mode and open all the ports. Okay, and then I'm going to use Docker ps -a to make sure that it's open. Okay, so are there any network guys here? Anyone who plays around network? So what's the interesting thing about this setup, that it's this port setup? What's interesting about it? Yeah, okay. Also, we're exposing it on 000, yeah. So pretty much anyone can see this, okay? So be very, very, very careful when you're doing this on an AWS machine, because as soon as you set it up on an AWS machine, you're going to open up this port to anyone. And you know, for those of you who got the little slip that I wrote some ports on, you know, actually I created AWS machines as plan B. So I've spun up multiple Chrome instances that you guys can access because I'm not, you know, restricting the access of people using Docker. So when you're using Docker, make sure you're not bounding things to, like you say, like a root or like a 000, because anyone can actually access it. Okay. So if you've got your Docker up and running, by the way, if you're on external server, like I say, bind it usually to the local if you're not going to use it externally. Okay, so let's quickly go and have a look. You know, is this Selenium Docker actually working? So I'm going to use tight VNC. So for the Ubuntu guys, you don't need a port. You're pretty much using, I think it's called Vinagre, or some viewer like that. It's just localhost. So if you're using Linux, it's not the IP I specified earlier. So, but if you're a Windows guy, it's this 192.168.99.100, and we're going to use that. So I don't know if you can see, but I'm using tight VNC because I'm on Windows now, and it's got a double colon, and you can see that I'm accessing this little server on 5901 because that's a port we exposed externally. And then it's going to pop up a little bit of a password, and guess what's the password? Secret, S-E-C-R-E-T, and you can see that in the Docker file. So if you go on to if you go and you look in, see if I can find this Docker file. I can't find it now. Oh, here we go. Control F secret. There you go. They actually tell you, well, if you prompted for a password, the password is secret. So also be aware of these kind of elements. Okay. So hopefully most of you can see this now. Who can't see this? Okay. He's going to help you out quickly. Okay, so it's almost break time, so I think let's quickly connect to this machine through R so we can actually see how this looks. So what I'm going to do is I'm going to load RSelenium, and I'm going to use the remote driver function. Okay, so on Windows, again, we're going to use this 192.168.99.100. On Ubuntu, you can just use localhost, or you don't actually need to even specify a connection to the remote server. So I'm going to load RSelenium. Okay, it's happy for that. I'm going to create with remote driver, specifying the IP. Remember, I opened port 445. Just add the L, so no, it's an integer. Browser is Chrome, so this is the type. This is not the name, that's just the type. Okay, and then I'm going to use RMDR, which is now my driver, which is I specified, and I'm going to use a function. So those of you who've used Java before or Python, you know, this should be familiar, you know, driver.open, so applying a method on a class of object, that's sort of how Selenium works. So as soon as I do this, what I see, going to connect to remote server, and there we go. And you should see that you've now created a nice new Chrome instance in your Docker, and it will tell you that Chrome is being controlled by an automated testing software. And that is half the battle won with RSelenium. And now the fun begins, but I think we'll get some coffee before then. Okay, so who is not at this stage? Okay, awesome. Okay, put your little sticker on, because I'm going to quickly come and help you guys before we get going.